I looked and I clicked, but I didn't click. So you want me to do anything about this, or can I continue? Now I'm recording, but I failed to record a few minutes. You want me to repeat any of this, or is it okay?
That's okay.
Yeah, so this was basically, yeah, I looked and I thought I did click and I didn't click. So you said it's okay. So if you want me, I can redo this in another video after class, if you need that. Okay. So now we are looking at page 5. So I have R. I have A prime of R. And I have A of R. Okay. So back to the drawing. So obviously R, so the whole thing is 28 meters. We can have R to be 0, and then it's the whole square. Or we can have R to be 28 over 2 pi. So it's the circle is the whole thing. So anywhere between 0, I'm not going to put infinity, 28 over 2 pi, because we're talking about R. Okay. And we found 1.96. Okay. So I go back to the first derivative and study the sign. Here's the first derivative. If I plug in 0, 0, this is going to be a negative number. If I plug in 10, this is going to be a positive number. Okay, so we know that this will be the minimum and the absolute minimum. But I do have to plug in 0 in the function. When I plug in 0, where's my function? Here's my function. So when I plug in 0 for R, I get 14 squared over 4. So what is 14 squared over 4? 14 squared divided by 4, 49. Okay, now I also should plug in this 28 over 2 pi to see what this value is. Okay, now I'm going to share my screen because it's a little bit more work, not just a simple number. So what was I having here? Yes, so I had in y equals 14 minus pi x close squared divided by 4, and then plus pi x squared. That was our function. And what I want to plug in here is that 28, what was it, divided by 2 pi. I'll explain in a minute what I'm doing. So let's see, it's going to give me the number here so I can see it's 43.44 roughly. So this is 9931. 9931. Okay, so this was meters squared because we're talking about area. And this was roughly 44. Okay, so let's take a look. What happens here? Okay. So, oh, I forgot to enter that 196. 1.96. I want to see what that is. 1.96. 27.4. As expected, this is the absolute minimum. No problem there. Okay. So I think we were asking to determine the maximum area. So let's do the full analysis right now. So if the radius, if we cut, I'll copy it here. Okay. So if the radius is 1.96, the absolute, I know it's not asking us for the absolute, so let's think for a moment. So if the radius is, so I determine the radius, so let me also determine x. So x was 14 minus pi r over 2. So when r is 0, this is 7, x is 7. And when r is 1.96, I'm going to determine x as well. And when r is 44, it means that x is 0. Okay? So when 2 pi r is the entire length, then x is 0. When r is 0, then we have the entire length of 7, of course. 4 times 7 is 28. But I also want to determine what x will be if r is 1.96. Last thing, and then I'll explain again. So we have 14. I didn't mean that. I meant this. 14 minus pi multiplied by 1.96, close, and divide by 2. 3.92. Okay. So final analysis. When r is 1.96 and x is 3.92, everything is in meters, the total area enclosed by the square and the circle is minimum, 27.4. If we have no circle, if we bend the whole thing into a square, the area is 49. Who cares? This means nothing. But if we bend the whole thing into a circle, then we do not have a rectangle, the square at all. Look at the area. So the maximum in this case is obtained when the whole thing is bent into a circle, and the minimum is when the radius is 1.96 and the length of the square is 3.92. The minimum area will be 27.4 square meters. If we bend everything into a circle, we have the absolute maximum of 9,931 square meters. Very interesting problem. Any questions on this? Thank you for choosing that. Is that clear?
So it does. So it asks for the should be used for the square in order to maximize the total area, and it asks for meters, just m.
Because yes, but we have to look at the areas, to make a decision. So
right.
for a maximum, x should be 0. No square at all. To obtain a maximum area, I have to look at the value of the functions. That's why we studied a max-min on a closed interval for something like this. So if I want a maximum area, I will not use a circle at all. X has to be 0. X is 7 when r is 0. X is 3.92 when r is 1.96. And x is 0 when r is this, roughly 44. So the first question is answered with x equals 0 for a maximum area. Once again, what was the second question?
To minimize the total area.
X has to be 3.92. I don't know how many decimal digits they want. but x has to be 3.92 for meters for a minimum area. That's why we need the table to analyze these, as we always do with a closed interval. And that's my analysis. So the minimum area is obtained when x is 3.92. The maximum area is obtained when x is 0.
Okay, I understand. It doesn't want 3.92 still. Yeah, so I probably do need more decimal places.
More decimals. So what does it say? How many decimals they want?
It does not specify.
Ah, in that case, if it's not specified, they want the exact. Okay, hold on. Okay, so they want this. They want this with R in it. Okay, hold on. So the first answer is correct, right? You put 0.
Yes.
Okay, that's okay. So now, because they didn't specify, it means that they want x. So we have r equals 14 over pi plus 4. We have to plug it in, because this was that 1.96. Okay, I didn't know they didn't want any decimals. Sorry about that. So let's take a look. So this is 7 minus pi over 2 times r, 14 over pi plus 4. So x equals 7 needs a pi plus 4. So 7 pi plus 28 minus 7 pi over pi plus 4. Okay, so you have to enter x to be 28 over pi plus 4. Don't enter it just yet. I want to convince myself that that is that 3.92. Just give me 1 second. 28 divided by pi plus 4. And it should be that 3 point, exactly. So you have to enter like this, because they did not specify decimal digits. So don't forget parentheses, or I don't know how you enter it, but it has to be 28 over pi plus 4.
Okay, yeah, it does not like that either.
Really?
Yeah.
So you enter it for x, 28 over pi plus 4? For x.
Yes.
Do they want the radius?
So for x, how much wire in meters should be used for the square in order to minimize the total area?
Ah, for the square. Then we have to multiply this by 4. Because this is just x. We have to multiply it by 4. So it would be x equals 112 over pi plus 4. So this is 4x. They're asking for 4x. 112 over pi plus 4.
That works for me.
Good, thank you. Yes, it has to be, if they're asking, say I didn't look at the problem, so I'm sorry, I should have looked at the problem and read it myself. So if they're asking for the length used for the square, then we have to multiply by 4, because the length is 4 times x. Awesome. Good. Other questions? Do you need anything else with WebAssign? So was it okay? The 112 over pi plus 4 for everyone?
Mm-hmm.
Okay, perfect. Awesome. Great. So do you have anything else, or can I go to this 39 on 4.3? Okay, so I'm on page 6. 39 in 4.3. If you find anything else, please throw it our way. Okay. I hope I'm not logged out. Okay. So I think we said that 39 was done in class, and if you want to choose a different one. I think. I'm not sure. Or was this the other one? So I don't remember, was 39 done in class and you want to choose 40, or I don't remember now. We said something like that last night. Is anyone with me?
Yeah, in my notes, we already did 39.
Okay, so we want to do 40 or something else?
Yeah, I think we did 40 for homework, but we can do it again in class.
Okay, do you want to do, for example, 41 then? I think we did 41 as well. I remember doing 41. Okay, what about 37? Okay, let's look at 37 then. So I have f prime of 0 equals f prime of 2 equals f prime of 4 equals 0. F prime of x positive for x less than 0 union 2 less than x less than 4. F prime of x less than 0 for 0 less than x less than 2 union x greater than 4. Second derivative positive for x between 1 and 3. Second derivative negative for x less than 1 union less than greater than 3. Okay. As you see, it takes us longer to copy this than to solve the problem or come up with an example. Okay, so let me see. I have, okay, let me